I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll solve one problem by using KNN algorithm, K nearest neighbor algorithm. All you know that the K nearest neighbor algorithm is a popular machine learning technique used for classification and regression tasks. It works by finding the K most similar data points, that is nearest neighbors to a new input and using their labels or values to make predictions. KNN is simple to implement, handles nonlinear relationship, and is robust to noisy data, making it suitable for various applications like image classification, recommendation systems, and customer segmentation. We'll solve one problem by using this KNN algorithm. And this is the problem statement. What is the statement of this problem is, so in this scenario, a telecom company wants to predict whether a new customer is likely to churn means leave the service or not, based on the behavior and history of existing customers. Churn prediction is crucial for telecom businesses to proactively retain customers and reduce revenue loss. We are using the K nearest neighbors, that is KNN algorithm, a simple yet powerful method that classifies new data points by comparing them to similar points in existing data. If most similar past customers left the service, the new customer is also likely to churn and vice versa. And this is the sample data set. We begin with a data set containing 5 records, first to 5, 1 to 5, previous customer, the records of 5 previous customers. For each customer, we have details like age, tenure means how many months they have used the service, monthly spend, support calls made, and whether they churned or not. The churn label is binary, that is, 1 indicates the customer left the company, 0 means they stayed. This structured data forms the training base for our prediction model. These labeled examples are essential for the KNN algorithm to compare the new customer with the similar past profiles. So for the 6th customer ID, we have to find out the first 4 IDs or the training data. The 6th one is the test data. By making use of this training, we have to find out whether it should be churned or not. So the new customer details, we have taken ID number 6. The age is 28, tenure is 4 months, monthly spend is $80, support calls are 4, and whether he will be churned out or not. The age is 28, tenure 4, monthly spend is $80, support calls 4. Goal is predict churn or not, that is 1 or not. So this says that now we are given a new customer's information without a known churn label. The customer is a 20 years old, has used the service for 4 months, spends $80 per month, and has made 4 support calls. Our task is to use the KNN algorithm to determine whether this customer will churn or stay. This test customer will be compared against the 5 existing customers to find the most similar ones. For that, we have to use the distance formula. That means the Euclidean distance we have to use for the calculation. If you are using this Euclidean distance, the formula is given by distance equal to x1 minus x2 the whole square plus y1 minus y2 the whole square plus z1 minus z2 the whole square plus w1 minus w2 the whole square. The x represents the age. What is the second column represents in this table? tenure, third column is monthly spend, and fourth column is support calls, spend and support calls. So we have to take the test data are 28, age is 28, tenure is 4 months, monthly spend is $80, support calls are 4, goal is predict churn is 1 or not. This we have to predict. So this is the formula. So to determine the similarity, we use the Euclidean distance formula, which calculates how far one customer is from another in terms of numeric attributes. The formula squares the difference in age, tenure, monthly spend, and support calls between two customers, sums them, and take the square root. This gives us a single number representing how similar each past customer is to the new customer. The smaller the number, the more similar they are. We'll see. So first, distance step-by-step calculations we'll look into. In this step, we calculate the Euclidean distance between the new customer and existing customer. For customer 1, the distance is, so we have to calculate like this. How we are going to calculate is, age difference is 28 minus, so in this table, the 28 minus 25 the whole square, we are getting, so fine, plus 4 minus 2 the whole square, plus 80 minus 70 the whole square, plus 4 minus 5 the whole square. If you are summing up, finally you are getting the value 10 point. So 28 minus 25, 9, plus 4 minus 2 is 4, 80 minus 100, and 4 minus 5 is 1. If you are summing up, we are getting the value for customer 1, the distance is root of 114. It is approximately equal to 10.68. This I have used the calculator and I have calculated. Everyone, you can take the calculator and use it. Distance to customer 2, age difference is 28 minus 45. If you are looking into the table, 28 minus 45, 4 minus 36 square, 80 minus 85 the square, 4 minus 2 the whole square. So we are getting the value 289 plus 1024 plus 25 plus 4, you are getting root of 1342, and if you are taking the square root, we are getting 36.63. Similarly, for the ID number 3, that is customer 3, age difference is 28 minus 30 square, tenure is 4 minus 12 the whole square, spend difference is 80 minus 60 square, and 60 the whole square, call difference 4 minus 3. So if you are summing up and taking the square root, you are getting a root of 469 is approximately equal to 21.65. And for customer ID 4, 28 minus 22 the whole square. So in the table you can able to easily find out 22 minus the 28 minus 22, 4 minus 12. So like that, 4 minus 3, 80 minus 65, like that we can able to find out. 80 minus 65, call difference is 4 minus 6. If you are taking the square, the minus will be getting cancelled. We are getting 4. So the distance is root of 36 plus 1 plus 2 to 5 plus 4 is equal to root of 226. It is approximately equal to 16.31. And for the customer 5, 28 age difference is 28 minus 35. The whole square is equal to 49. Tenure difference is 4 minus 6. The whole square is equal to 4. Spend difference is 80 minus 90. The whole square is equal to 100. Call difference is 4 minus 4. The whole square 0. 49 plus 4 plus 100 plus 0 root of 153 is equal to 12.37. Each distance tells us how close each customer is to the new customer in terms of service behavior. These values are critical for the next step in identifying the top K neighbors. Coming into the distance summary table, so we have, these are all the training data. We found out for the ID 1 10.68, ID number 2 customer ID 36.63, by making use of the new customer 16.31, and finally we got 12.37 respectively. So if you are arranging these values, we now organize the result into summary table listing the customer's ID. They calculate a distance to the new customer and their churn status. This table allows us to quickly sort and identify which customer are the most similar. From this table, we see that the customers 1, 5, 4. See here 1, 5, and 4. These values are, it is nearby, similar values, almost similar, which customers are most similar. So in this table, closest to the new customer with distance of 10.68, 12.37, and 16.31 respectively. And seeking, we are keeping a k value. So here we are arranging and the according to the value 154. So these values according to values 111, these values gives us already the churn value is 1. So we are arranging like this. Next, we are selecting case equal to 3, nearest the 3 neighbors. Next, we choose case equal to 3, which means we look at 3 closest customers. Who are all the closest customer? 1, 5, and 4. So we are choosing case equal to 3, which means we look at 3 closest customer to the new customer based on the calculated distance. From our summary table, these are all the customer 1 is churned, customer 5 is churned, and customer 4 is churned. These are all the customers whose behavior most closely resembles that of the new customer. Next, we have to go for, so here customer 1 value is 10.68, 12.37, 4 is 6. These values are, these all threes are churned. Next, we have to go for voting. KNN uses the simple majority vote among the k nearest neighbors. In this case, all three nearest neighbors have a churn value of 1. See here, we can look into all values are 1, meaning that they left the servers. Since 100% of the closest customer churned, it is highly likely the new customer will churn too. The vote is clearly in favor of predicting churns equal to 1. So the customer will churn. I hope everyone understood. Churn 1 occurs 3 times, churn occurs 0 times. So among these 3 neighbors, so based on this prediction, we can, majority voting is 1. So the customers, the vote is clearly in the favor of predicting churn 1. So coming into the conclusion, based on the voting, the result from the top 3 most similar customers, customer 1, 5, 4, we predict that the new customer will churn. This conclusion is grounded in the strong pattern observed in the nearest neighbors. And KNN has helped us make a data-driven decision by using similarity-based classification, which is ideal in situations like churn predictions, where behavior patterns are a strong indicator of future outcomes. Hope everyone understood the concepts of this KNN algorithm for this problem. The remaining things we'll discuss in the next lecture. Thank you.